You're welcome to my YouTube channel. This is lecture 4 of the Mathematical Methods 1. Our topic for today is Introduction to Partial Derivative. If x z is equal to f of xy be a function of two independent variables x and y, then to differentiate z partially simply means first order partial derivatives are dz partial z partial x and partial z partial y. This is for first order partial derivative. Now to find partial z partial x, you differentiate z with respect to x, taking y as constant. Then to find partial z partial y, you differentiate z with respect to y, taking x as a constant. Second order partial derivatives are, you see them here, fxx, fyx, fxy, and fyy. These are for second order partial differentiation twice. Now remark, you should know that fxy is equal to fyx, so they are symmetric. The process of differentiating y equal to f of x is called ordinary differential, while if u is equal to f of x1, x2 up to xn, then first order partial derivative are partial u, partial x1, partial u, partial x2, and we continue to partial u, partial xn. Similarly, we can find higher order partial derivatives. Let's look at some examples. Find the first order partial derivative of the function u equal to y raised to power x, z equal to log x squared plus y squared, z equal to arc cos x over y. Solution for A, let partial u partial x be equal to partial y raised to power x dx, and that will give us y raised to power x log y. Taking y as constant, then use the derivative for x a raised to power x. You're going to get a raised to power x log a dux. Partial u partial y of y raised to power x will give us y x y raised to power x minus 1. Taking x as constant, then use this. Okay. Now for B, partial z partial x is equal to partial log x squared plus y squared dx, partial x, and that will give us 1 over x squared plus y squared partial x squared plus y squared partial x with respect to x. And when you continue the derivative, you are going to have 2x over x squared plus y squared. Since z is equal to log x squared plus y squared symmetrical with respect to x and y, as we get same function after interchanging x and y, hence to find partial z partial y, interchange x and y, therefore partial z partial y will still give us 2y over x squared plus y squared. Let's look at C, partial z partial x. Okay, it's going to give us minus 1 over square root of 1 minus x over 2 or squared partial x over y. And when you take the derivative, you're going to have minus 1 over square root of y squared minus x squared. Then, and partial z partial y, remember the first one we did is partial z partial x, so partial z partial y, you're going to have equal to minus 1 over square root of 1 minus x over 2 squared partial x over y. And when you take the derivative properly, you're going to have x over y square root y squared minus x squared. Worked example. If u, which depends on x, y, and z, is equal to log tan x plus tan y plus tan z, show that sine 2x partial u partial x plus sine 2y partial u partial dy plus sine 2z partial u partial z equal to 2. Solution. Differentiating u partially with respect to x, we get the u dx to be 1 over tan x plus tan y plus tan z sec squared x. That's the derivative. Then similarly, partial u partial y, then partial u partial z will give us, for partial u partial y, you have sine square y over tan x plus tan y plus tan z. While for partial u partial z, you're going to have sec squared z all over tan x plus tan y plus tan z. So the left hand side will give us this, which is sine 2x times sine square x plus sine 2y plus dot sine square y sec squared y plus sine 2z times sec square z all over tan x plus tan y plus tan z. And when you simplify properly, you're going to have equal to 2, which is equal to the right hand side. So the left hand side is equal to the right hand side. We have been able to show that. Now let's look at this worked example. If exponential raised to power minus z over x squared minus y squared is equal to x minus y, then show that y dz dx plus x dz dy is equal to x squared minus y squared. Solution. Taking log on both sides, we have minus z over x squared minus y squared equal to log x minus y, which implies that minus z is equal to, that is cross multiply, minus z will be equal to x squared minus y squared log x minus y, or z is equal to y squared minus x squared log x minus y. Now differentiating equation 1 partially with respect to x and y, we get this partial z partial x will give us 0 minus 2x log x minus y plus y squared minus x squared times 1 over x minus y in bracket 1 minus 0. Therefore, y partial z partial x is equal to minus 2x log x minus y plus y in bracket y squared minus x squared all over x minus y. And partial z partial y will also give us 2y minus 0 log x minus y plus y squared minus x squared times 1 over x minus y in bracket 0 minus 1. Therefore, x dz dy is equal to 2xy log x minus y minus x in bracket y squared minus x squared all over x minus y. Adding equation 2 and 3 together, we get y dz dx plus x dz dy is equal to y minus x y squared minus x squared all over x minus y. And that is equal to, after proper simplification, you're going to have x squared minus y squared. Let's look at another worked example. If u is equal to x squared arctan y over x minus y squared arctan x over y, find the value of partial square u over partial x partial y. Solution. Let the u dx partial u partial y equal to x squared times 1 over 1 plus y over x squared times 1 over x minus 2y arctan x over y plus y squared times 1 over 1 plus x over y squared times x in bracket minus 1 over y squared. So when you simplify properly, you're going to have that x times x squared over x squared plus y squared minus 2y arctan x over y plus x times y squared all over x squared plus y squared. And when you continue the simplification, you're going to have that, therefore, partial u partial y will be equal to x minus 2y arctan x over y. Hence, partial squared y over partial x partial y will be equal to 1 minus 2y times 1 over 1 plus x over y squared times 1 over y. which when you collect like terms and simplify properly, you are going to have x squared minus y squared all over x squared plus y squared. Now, another subtopic, total derivatives. If u is equal to f of x, y, and z, and x, y, z are functions of t, then total derivative of u is du dt given by du over dt is equal to partial u partial x times dx dt plus partial u partial y times the y dt plus partial u partial z times the z dt. That is the formula for total derivative. Now, find the total derivative du dt if u is equal to x raised to power 3 plus y raised to power 3 and x is a cos t, y is b sin t. Solution. Let du dt be equal to partial u partial x times dx dt plus partial u partial y times the y dt. Now, when you do that properly and you simplify, you're going to get 3 sin t cos t times b squared sin t minus 8a cubed cos t. Now let's look at another example here. Find du dt as a total derivative and verify the result by direct substitution. If u is equal to x squared plus y squared plus z squared and x equal to e raised to power 2t, y equal to e raised to power 2t cos 3t, and z equal to e raised to power exponential raised to power 2t sin 3t. Solution. For the total derivative du dt, you have partial u partial x times the x dt plus partial u partial y times the y dt plus partial u partial z times the z dt. And when you do that properly and you substitute, you're going to have 2x times 2 exponential raised to power 2t plus 2y times 2 in bracket times 2 times exponential raised to power 2t cos 3t minus 3 exponential 2t sin 3t plus 2z in bracket open and close 2 exponential 2t sin 3t plus 3 exponential 2t cos 3t. Now when you continue with the expansion and collection of terms, you're going to have 4 exponential 4t plus 4 exponential 4t, and that will give us 8 exponential 4t. Now let's verify by direct substitution. Put values of x, y, and z in given u. We get u equal to this. Okay, e exponential raised to power 2t squared plus e raised to power 4t cos square 3t plus exponential 4t sin square 3t, and that will reduce to 2 exponential 4t. Therefore, the total derivative du dt will still give us 8 exponential raised to power 4t. Thank you very much for listening.